Start the recording, screen, entire screen, share. There we go. Hide. Okay, so if we go over to which business to buy. So if we look at the comparison, this is the comparison that I gave. So this is a comparison of two businesses. One has 60% fixed cost, 30% variable cost, and the other one has 50% variable and 40% fixed. So restaurant B being higher, having higher operational leverage. Now what happens if we increase sales by 10%? Let's see the changes in net income and costs. So for restaurant A, let's take our sales here and multiply it by 1.1, which is 10%. And our variable cost is 50% of our sales. Okay. Multiplied by 50%. And then let's do the same for restaurant B. Our sales are increasing by 10%, so multiplied by 1.1% or 1.1. You'll notice that both the sales for both restaurants is still the same. Calculate the variable cost based on the cost percentage of 30%. There we go. So you'll notice between the two here, both restaurant sales increased by 10%, but the restaurant that had the higher fixed costs or higher operational leverage has the higher operating income. And the restaurant or the business that had the lower fixed costs, sorry, the higher variable costs, had the lower operating income. Why do you think that is?
Well, if your variable costs are related to sales.
Yes, absolutely.
So if you have higher variable costs, the more your sales go up, the more your variable costs. That ratio is going to remain constant.
Exactly. So while you're exactly right. While our variable costs per unit or our variable cost percentage stays the same, it's higher than our fixed costs. So as our sales increase, our total variable cost must increase with our sales. However, our variable costs will not. So with increasing sales, we see increasing variable costs, but our fixed costs stay the same. So this would make an operation in comparison to an operation with high operational leverage, it would show it as less profitable, because if you have more fixed costs that don't change with sales increases, then your costs stay largely the same. I mean, your variable costs are going to go up to some degree, but if you have a high degree of operational leverage, then it won't go up nearly as drastically as a company that has higher variable costs. And this is an interesting point because this happens in academia as well. So I'd say a rate around like 80% of college faculty are contract staff. So I'm not full-time. I'm technically a variable cost to the college. I get paid by the amount of hours I'm in class, whereas a full-time professor does not get paid based on the hours. They get paid a certain salary regardless of whatever they do, right? Now, the trend was with colleges and even universities, they're all going the part-time way now because they want their costs to be in proportion to that of their sales. Reason is because the income or sales for academic institutions are not going up, they're going down. So that's why they want higher variable costs, and I'll show you that here right now. So if we go down to the next one here, we have a comparison of the two businesses with a 10% decrease in sales. So we take our original sales and multiply by 0.9 or 1 minus 0.1. So we got a dollar sales of 90 grand. It'll be the same for both. Variable cost still 50% for restaurant A. And variable cost is still 30% for restaurant B. You'll notice that during times of sales declines, that the company or the restaurant that has higher variable cost has the higher net income. That's because your fixed cost is staying the same. However, your variable cost, or the biggest chunk of your cost structure, is variable based on sales volume.
Shouldn't that variable cost in restaurant A be 45,000?
Hold on. Did I do that wrong? I totally did. 19 times 50. There we go. So still higher, different number. Still higher than restaurant B. So businesses with high operational leverage do better have higher net incomes during periods of sales growth when compared to operations that are not as highly leveraged. On the other hand, operations that have high operational leverage have less or have poor performance in times during the sales declines. So in talking about which business you should buy, restaurant A or restaurant B, it really depends on what you anticipate the sales being, right? Are you anticipating your sales increasing? Is this restaurant experiencing sales growth? If it is, you would probably pick restaurant B, because restaurant B financially performs better during sales growth periods. However, you would really need to be cautious because it will underperform financially when there are times of sales decline. To further this, if we come down to the little bottom here, I'm going to erase these two because I've obviously given you the answers. If we take the fixed costs from restaurant A, which I just deleted, there we go. The fixed costs from restaurant A and divide it by the contribution rate, which is the contribution margin divided by sales, we get 800,000. And if we take the fixed costs from restaurant B divided by the other contribution rate, we get 857,000 and change. What this means is that if you purchase restaurant A, your break even is $80,000. Sorry, $800,000. Restaurant B, your break even is $857,000. If your current sales are at $1 million? If your current sales are at $1 million, you would be, restaurant B definitely outperforms restaurant A during sales growth. However, it also has a higher break-even point, which means that restaurant B would be very sensitive to sales declines, because under 857,000, you're going to be losing money. However, restaurant A, the cost structure is not suited towards sales growth. However, it does have a much lower break-even point, and thus could still perform well during sales slowdowns. And it would take a while for someone to be concerned that restaurant A would be losing money because it has a lower break-even point. So it really depends. When you're looking at a decision like this, you have to really decide: are sales going up? Are they going down? How intense are the seasonalities? Like, does one of your seasons drop below the break-even point per month? I don't know, but this will help you in making that decision. You know, if the business that you're looking into buying is going through huge growth phases, you probably wouldn't be too worried about the break-even point because you're already above the break-even point. And your company will be able to outperform others financially during that growth period based on the cost structure. On the other hand, if you were anticipating like a sales slowdown in the industry, then you would pick restaurant A because restaurant A outperforms other restaurants during sales slowdowns and has a lower break-even point. It's a much more conservative decision, I think. So it's kind of up to you. Debrief. Which one you should be choosing? Kind of said it depends on sales indexes. If your indexes are showing consistent sales growth from period to period to period, from year to year to year, and your growth is relatively assured for the next couple of periods, you would probably pick restaurant B because restaurant B outperforms restaurant A given its cost structure. This example also has implications for you starting up your own restaurant. At some point, we can change our cost structure. When you first start up your restaurant, you would probably want to start up your restaurant with higher variable costs. Reason for that is you will typically have a lower break-even point, and you will outperform in comparison to highly operationally leveraged. You'll outperform other restaurants at the same sales level because of your cost structure. Once your sales are increased and you're experiencing growth, like year over year, month over month growth, like excluding seasonalities, of course, you could switch your cost structure to be more to have a high level of operational leverage. That way, you're outperforming others or you're outperforming yourself financially during sales growth periods. Okay, so another consideration we must make is sometimes we have the option of paying a fixed or variable lease. I've never seen a variable lease ever. The idea is that a variable lease, the amount of rent you pay is a percentage of your sales. Yeah.
That sounds kind of awesome, but like
what if you sell like a lot and then
yeah. So if your sales increase 10% and you're paying 6%, yeah. So there's a portion of your sales increase that is not going to your bottom line, it's going to a cost. So I've never seen that in place, but it's the same idea as our previous example, is that if you're going to be experiencing growth, it's better just to pay the fixed cost lease because it's a fixed amount. It's not going to change. Opposed to paying a variable lease, where if you have increasing sales, the amount of your lease is going to be increasing as well.
I can actually.
sorry. Go ahead.
I was just going to say I can actually suddenly think about an example of a variable rent, but not a permanent lease, but like with like events, like a lot of times like bars will actually take the rent will be a percentage of sales. Yeah. Or like with like concert promotion and stuff like that. Like
hairdressers do the same thing.
The venue does a percentage of sales.
Yeah.
So actually that does exist, but I can't see it for restaurants.
I don't think in our industry. Typically you'll just have a fixed rent. But if you are offered variable rent or a variable lease, if you take the fixed cost lease divided by the variable cost lease, that gives your sales point of indifference. Basically, at that sales level, you don't care whether it's fixed or variable. Above sales, if your anticipated sales are going to be above that point of indifference, you should pick a fixed cost lease. If your anticipated sales are below that point of indifference, then you should pick a variable cost lease. However, in my opinion, your restaurant is going to have seasonalities, right? Not just on a per month basis, but also on day of the week basis. Friday's busier than Mondays for the most part. January is busier than May for some restaurants. December is busier than March. It really depends. So your sales are going to be going up and down quite drastically. It's best just to pick a fixed piece, because at least it's consistent, and you can make decisions based on something that is fixed, opposed to something that is variable. Easy. So next week we're going to be talking about CVP, and to really understand and make sense of CVP, we look to this equation. Like everything in CVP boils down to this equation. If you're really good at math, you'll love this. Like this, check it out. Sales equals variable cost plus your fixed cost plus your profit. Now the problem here is we have a thing called semi-variable costs, and semi-variable costs are both variable and fixed. However, we don't know to what degree they are variable or fixed. We just know that they have a fixed or variable component. So we have to separate our fixed costs and to be able to apply our CVP equation and CVP analysis. Well, to do one accurately. To do that, there are 3 methods. Only one needs to be applied. One is more accurate than the rest. The 3 methods are the high-low method, the multi-point graph method, and then the regression analysis method. You can already tell which one is going to be the most. It's nothing like saying the word regression. Regression analysis has been viewed or is viewed as the best way to analyze a relationship between an independent and a dependent variable, while the other two, there's some major limitations. The high-low method includes 3 steps. There's a 3-step program to calculate variable costs per unit or per guest. And if you know the variable cost per unit or per guest for a particular cost item, then you multiply it by the certain amount of guests to be served and subtract that from the total cost item, and that'll be the fixed portion. So your variable cost per guest is the dollar change in cost divided by the dollar change or dollar change in guests or units. So the amount of money that they produced. So we'll show this on Collaborate because it's easier done with Excel. Am I still sharing this? Yep. So we go to the high-low method here. So here, of course, I have, jeez, I always do this. So here is, sorry, there we go. So here is some information. We've got months January through December. We have the number of guests we served and the wage cost. So this is the labor cost, being salaries and wages. We have the labor cost and guests served for each month. So we go through each month and we pick out the highest month, or we pick out the month that has the highest guest counts and the highest labor. And then we go through and we find the month that has the lowest guest counts and the lowest labor. Now that we know which ones they are, so right here we have August is the highest, having served 2,100 guests and has a labor of $26,400. The low was February with 500 guests and $14,400 in labor. If we calculate the difference between the two, so for guests served, it'd be 2,100 minus 500 equals 1,600, like that. And then the difference for our wage cost is 26,400 minus 400 gives us 1,200. Sorry, 12,000. If we take the dollar change in the cost right there and divide it by the guest change, the change in guests served, we get $7.50. What that is the variable component for your labor. So every guest that you serve, it's going to cost you $7.50 variable labor cost to do that. So how we apply this is we can calculate the variable component based on the guest counts. So if we take 500 guests in January, multiplied by $7.50 per guest, we get a variable component of our wages, of our labor to be $3,750. If we do that for every month, so we're just going to click and drag all this stuff like that. Just make sure it's right here. Yeah, so it's multiplying every month's guests served by $7.50. We get all the variable components of our labor cost. Now, if we go over here, we took our total wage cost and minus our variable component, we get the fixed component of our labor cost. So the total labor minus the total variable labor must equal the total fixed labor, or salaries. So if we copy that equation all the way down, there you have it, sports fans. We have both the variable and fixed component of our labor. We've taken a semi-variable cost and we've separated it into the variable component and the fixed component so that we can lump those costs into this equation here, being either fixed or variable. However, we still have more methods to go. We have the multi-point graph method. And if we're still on Collaborate, we're just going to move over. There we go. So if I go over to our multi-graph point, using the 12 months of guest information, so we have our number of guests, and we have the labor cost. If we plot those out on a scatter point, we can kind of guesstimate the fixed portion of our labor. So here on Collaborate, I've taken the information from the scatter plot, the information that we were just working with, and I've graphed it on a scatter plot, and then I've added a trend line. So this trend line is it's also a line of best fit, or a line of linear regression. This line shows the relationship between those two variables, and it shows that there is a positive relationship between the two. As one increases, so does the other, typically speaking. So what is that called? That's called a positive. I think it's a positive relationship. Yeah, okay, we'll call it a positive relationship. I'm not an economist, okay? So we have an increasing line, so the slope is a positive number. Now, this alone doesn't really tell us exactly what our fixed costs are. It just shows us that as our sales go up, or as our guest counts go up, so does our labor. What we can do here is if we right-click, you go to Format Trend Line, it brings it up. We set intercept. Oh, sorry, don't set intercept. Oh, wait, what did that do? I don't know why it's doing that. Anywho, go to backwards. Let's hit 3 to see what that does. Okay, that obviously did nothing. 15. Am I missing something here? Ooh. Go to Format Trend Line. Go to back. What is it? 400 periods, maybe? There we go. And that will say another 50, 450. So what we're doing is we're moving the trend line back as close as we can get it to. There we go. As close as we can get it to the y-axis. The intercept of that linear regression with the y-axis, that at that point you're fixed. That's the point of your where there's 0 guests served, but there's still a cost. That is the fixed cost portion of your of your labor. Sorry, I'm just trying to get the where is it here? So at this, you kind of have to like guesstimate. Like, I think at some points you can add in the legend trend line. Oh, it doesn't tell us. So roughly 80. What does that say? 80,000? Anyway, it's that y-intercept. That is the value of your fixed cost portion. There's a huge amount of limitations to this particular method. Our textbook says that we should be doing this by hand and drawing the line of best fit with a ruler. I don't know, but that sounds pretty Stone Age to me. You can do it on Excel. However, you have to be able to format the graph properly. For instance, this graph is not properly formatted. You would not get an accurate picture of what your fixed costs actually are. It's just the logic is sound, is that if our labor should follow a relatively linear line, as is a variable cost, right? MX plus B, MX being the variable portion of our labor, B being the y-intercept, is also the fixed cost portion of our labor. So I get the logic, it makes sense, but I don't think you'll probably be using this very much.
Question.
Yeah.
So I'm just like having an kind of inherent mental problem with this, because like, isn't by definition your fixed cost fixed? Like even with labor, like you're not, like if you have a manager's salary,
Yeah.
it's not going to change monthly.
No, but the more you use hours, like more hourly people, your total labor would go up, right? But there's still a portion of that labor cost that is fixed.
Yeah.
Yeah.
Then why does that fluctuate so much?
How do you mean?
Well, when you did the
The high-low method, yeah.
Yeah.
So between all of these methods, because they're different methods using different equations, they will have different results. And they can have like drastically different results. Due to the limitations of each, I suggest that you use the regression analysis to calculate the value of your fixed costs for your labor. This can be used as a quick method. The other one's pretty quick as well. But they're all going to come up with different numbers, which is why I'm recommending that you use the regression analysis. Okay, does that help? A little bit? Okay. Sorry. Lastly, we're going to talk about a regression analysis. A regression analysis is a statistical form of modeling that helps us understand the relationship between an independent and a dependent variable. In our case, the independent variable is what? Our independent variable is our guess counts. It's our guess counts that dictate what our total labor is going to be, right? So knowing that, we can go to our regression analysis here. So we're going to use the same information that we were using before, but in a different way, just like the other methods. We have to do a few things first before we can actually do a regression analysis. Just change here. Your fixed costs are equal to the sum of y multiplied by the sum of x squared minus the sum of x multiplied the sum of xy divided by n being the time periods, this multiplied by the sum of x squared minus the sum of x squared. And of course that e thingy equals sum or total. So that was super crazy. I'm going to break it down so it's not so crazy. Okay, so first, if we look on Blackboard here, we've got the same information we started with. We've got our guess serves as the independent variable and our wave cost as the dependent variable. In this column here, we're going to multiply x multiplied by y. And that gives us for one period the value of xy. Yeah, so we'll do that for every period. So 500 multiplied by our wage, that, and we get a crazy number. We're going to do that all the way down. So we're just going to, and then add them all up at the very bottom under the total, which is the exact same. And then in the next column over, we're going to calculate x squared, which is x multiplied by x. So it would be the individual, the x squared for each period. So we square 500, so it'd be x multiplied by x for each month, and we drag that all the way down to get the x squared for each month, and then we add them all up. Like that. Beautiful. Okay, so now, if we look at, I'm going to bring you with me. If we look at this stunning thing right here, our fixed costs are equal to the sum of y. If you look at your chart here, y is your wage cost. At the very bottom, we have the total being $241,600. That's the sum of y, multiplied by the sum of x squared. You have x squared, or the sum of x squared on this sheet as well. It's the very bottom of x minus x. Or, yeah, the total of x minus x, which is, I'm trying to point to my finger right there. So we multiply those two together, and then subtract the sum of the x's, which we also have here, multiplied by xy, which we also have, and then n. So we're going to do it on Collaborate right now. So here we go. We take the sum of y, which is right here, multiplied by the sum of x squared, which is right here. And sorry, I'm just going to put a bracket in here because I think that's what's going to happen. And then we minus sum of x multiplied by the sum of xy. Okay, and now then we divide that by how many are there here? There's 12 months. 12 months. I'm going to put a bracket in there as well. There we go. Multiplied by x squared, or the sum of x squared. Why won't it let me click it? There we go. Minus x squared itself, or the sum of x squared itself. Did I get that closed right? Sorry, just put another bracket in here because if we don't do the brackets, okay. So once we've put in that equation, we hit OK, and our monthly fixed wages in this case are $1,139.56. Now, if you didn't get exactly what I just got, it could be because of bed mass. You ever see that thing on Facebook? It's like 5 plus 6 minus 2 divided by 3 multiplied by, it's bed mass. So you got to make sure when you're inputting the equation into Excel that you've got an extra bracket right here. And an extra bracket right here. Because if you plug this into your calculator, it would be very difficult to plug this into your calculator. But plugging this into Excel, you have to make sure that this is being divided by this. So you have to put in the extra brackets. You can do this with You can do this with your total labor. You can do this with your utilities. You can do it with other semi-variable costs as well. Again, what it's doing is separating the fixed component from the variable component. So while the regression analysis is probably viewed as the best one to use to measure that relationship between the independent and dependent variable, it does have some limitations, of course. Others have more severe limitations than the regression. For instance, a multi-point graph, if completed by hand, is very limited to the person's ability to draw a straight line. I have lots of coffee, which means that my hands tend to shake sometimes, meaning I will not be able to draw a straight line. So don't use that one. The high-low method, while a bit better than the multi-point graph method, I think, is only limited to 2 periods worth of information. It's only considering the high point and the low point. It's not considering 12 months. It's only considering 2 months. So it's not as much information. Where the multi-point graph does come into, or the multi-point graph analysis, where that does come into play a little bit, is with forecasting. Just like if you go back to our multi-point graph here, just like I could move the trend line backwards to show where that trend would connect with the y-axis, I can extend that trend forward into the future. So I can, in theory, predict sales as well as costs. It's not a terrible, it's not the best way to do it, but it's still useful. I'll also be showing you how to use the forecast function, or the forecast function in Excel. Hopefully the computers, you have it, maybe, I hope. Because the forecasting function saves you a ton of time. Okay. So that's it. That's all we have today. Does anybody have any questions? It's so quiet. Okay. That's good. That's good. So tomorrow, when I say tomorrow, of course, I mean next week. Next week we'll be talking about CVP, and we'll be talking about budgeting. CVP, I don't think it will be too terrible because you already seem to kind of understand the concept. Budgeting might be a little bit difficult, only because there's forecasting involved, but it should be fine. It should be. Down here. Those egg wraps are killing me.
How are you feeling with Mark?
I don't know.
You want it?
Oh yeah, good luck.